Children, it is a continuation of the chapter Gravitation. Now let us discuss about the motion of objects under the influence of gravitational force of the earth. Now you do one activity. Take a sheet of paper and a stone. Drop them simultaneously from the first floor of a building. Observe whether both of them reach the ground simultaneously. We observe that paper reaches the ground little later than the stone. This happens because of air resistance. The air offers resistance due to friction to the motion of the falling objects. The resistance offered by air to the paper is more than the resistance offered to the stone. If we do the experiment in a glass jar from which air has been sucked out, the paper and the stone would fall at the same rate. If the earth is not enclosed by the surface of air, then we can observe that both the stone and paper reaches the earth simultaneously. But because of the resistance of air, the paper falls little later than the stone. Here the paper and stone are having different masses, and the time taken to fall on the earth is same in the absence of the resistance. So if there are no resistance, you can see that both the paper and stone reaches the earth simultaneously. Therefore here mass of the object is not a matter. We know that an object experiences acceleration during free fall. This acceleration experienced by an object is independent of its mass. Even though they are having different mass, they experiences equal acceleration. It means all objects, hollow or solid, big or small, should fall at the same rate. According to the story, Galileo dropped different objects from the top of the Leaning Tower of Pisa in Italy to prove the same. Therefore, we can say that the acceleration experienced by an object is independent of its mass. All the objects, hollow or solid or big or small, whatever it may be, here they should fall at the same rate as they are experienced by the same gravitational force of the earth. So you know that you write the acceleration experienced by an object is independent of its mass. Is independent of its mass. Of its mass. All objects should fall at the same rate. Should fall at the same rate. Now let us discuss about the equations of motion for an object under the influence of gravitational force of the earth. Already you learnt about the three equations of motion. When u is the initial velocity, v is the final velocity, and t is the time taken, and s is the distance travelled, and a is the acceleration. And when the body is moving under the influence of gravitational force, Here the acceleration is considered as acceleration due to gravity. Acceleration is considered as acceleration due to gravity, that is A equals g. And when the body is moving under the influence of gravity, it moves upward or downward. So let us have S is nothing but height of the object, from the height at which it is dropped or at the height at which reaches, and time only, and u and v are the same here. So then first equation that you know, first equation is what? V is equals to u plus at. So here the first equation becomes V is equals to u plus gt. So you write that equations of motion for the object moving under the influence of gravitational force of the earth are: first one, V equals u plus gt. So in the place of A we have to write g. The acceleration is here acceleration due to gravity. Second equation, you know, second equation is S equals ut plus half at square. So then it becomes, in the place of S what we have to write, that is h. H equals u into t, ut plus half into a into t square, ut plus half at square. But here what you have to write? You have to write that half gt square. Half gt square. In the place of a we have to write g. Next, third one, what you have to write? V square equals, here what is that equation? V square equals u square plus 2as. It becomes V square equals u square plus 2gs. That a becomes g. Then these are the three equations of motion. When the object is moving with the initial velocity u, final velocity v after time t, and reaches, travels a distance s with an acceleration a. But here the s is nothing but the height and a is the acceleration due to gravity. So in the place of s we have to write h, and in the place of a what you have to write? G. So which are the three equations of motion for an object under the influence of gravitational force of the earth are: first one is V equals u plus gt. V equals u plus g into t. Second equation is h equals ut plus half gt square. H equals u into t plus half into g into t square. Then the third equation of motion under the influence of gravity is V square equals u square plus 2 into g into s. Here we have to note that the only difference between the equations of motion for objects moving along a straight line is that in place of acceleration a we have to write the acceleration due to gravity g. So what is the only difference? The only difference between the equations of motion for object moving in straight line is that in place of a what you have to write? G. Observe the equation. V equals u plus gt. Here in the straight line v is equals to u plus at. H equals ut plus half gt square. Here it is s equals ut plus half at square. V square plus u square plus v square equals u square plus 2gs. Here v square equals u square plus 2as. Now, if an object falls vertically downward, then acceleration due to gravity is taken as positive. Then the equations becomes all are plus. If an object is thrown vertically upward, then the acceleration due to gravity is taken as negative. Means its velocity decreases as it moves upward. So then the equation becomes V is equals to u minus gt, h is equals to ut minus half gt square, and v square equals u square plus u square minus 2gs. Here when the object moving upward, when the object moving downward. Because here the acceleration due to gravity becomes negative when the objects are moving in the opposite direction of the acceleration, that is gravitational force. If an object is dropped freely from a height, its initial velocity u is 0. When it is dropped from a height, initial velocity is 0. If an object is thrown vertically upward, its final velocity v becomes 0. Time taken by an object to fall from a height is same as that taken by it to rise the same height. So you write that here. So you take note here. First one is, if an object falls vertically downward, if an object falls vertically downward, then acceleration due to gravity is, then acceleration due to gravity is taken as positive. So the equations are same. It is v is equals to u plus gt, s is equals to ut plus half gt square, and v square is equals to u square plus 2gs. Right? Because its velocity increases while falling. Because its velocity increases while falling. Second, if an object is thrown vertically upward, if an object is thrown vertically upward, then acceleration due to gravity is taken as negative. Because its velocity decreases as it moves upward. Its velocity decreases as it moves upward. Then you take the third one. If an object is dropped freely from a height, its initial velocity u is 0. Its initial velocity u is 0. that is u equals 0. Next one, if an object is thrown vertically upwards, if an object is thrown vertically upwards, its final velocity v becomes 0. Its v becomes 0, that is v equals 0. Time taken by an object to fall from a height is same as that time taken by it to rise the same height. Time taken by an object to fall from a height is same as that taken by it to rise the same height. Yeah. While writing the equation and substituting the values, we have to note down the values of u, v according to the situation, and also value of g we have to take positive or negative depending upon the direction of the movement, whether it is vertically downward or vertically upward. Now let us solve the examples based on the equations of motion under the influence of the gravity. The first question is, a car falls off a ledge and drops to the ground in 0.5 seconds. Let g equals 10 ms to the power of minus 2. First one, what is the speed on striking the ground? Second question, what is its average speed during the 0.5 second? And how high is the ledge from the? So here, first one, you take the solution for the first one. Here what you have to find out, what is the speed on striking the ground? That becomes the final velocity v. And when, just like it is an object dropped from the particular height, then you take, when the object is dropped from particular height, its initial velocity is considered to be 0. So you take u equals 0, and then time taken to reach the ground is 0.5 second, and acceleration due to gravity g equals, that is 10 ms to the power of minus 2. That is positive because the object is falling towards the ground. It is dropped from the height. So what you have to find out here? We have to find out the first case, the speed on striking the ground, that is the final velocity v equals question mark, that you have to find out. Then you write the formula for v equals, what is that, u plus gt. v equals u plus gt. U is 0, the initial velocity is 0, plus g is 10 and t is 0.5. So then 10 5s are 50, that is 5.0. So that becomes 5 ms to the power of minus 1. You got that v is equals to 5 ms to the power of minus 1. That is the answer for the first question. Then you take the second one. what you have to find out, what is its average speed during the 0.5 second. In the second question, what you have to find out, we have to find the average speed of the car, that is in 5 second, 0.5 second. Then here the initial velocity u is 0 and final velocity v you got, that is 5 ms to the power of minus 1. The average of the two, initial velocity and final velocity, average speed equal, you can write in the initial speed plus final speed divided by 2, u plus v by 2 you can use here. So you write u equals 0, v equals 5 ms to the power of minus 1. Then what you have to find out, average speed equals question mark. Average speed equals question mark. Then you write the formula for average speed. So you write average speed equals u plus v by 2. u plus v by 2. u is 0 ms to the power of minus 1 plus v is 5 ms to the power of minus 1, that divided by 2. You know that 0 plus 5 is 5 by 2 equals 2.5. 5 divided by 2, you know, that is 2.5 ms to the power of minus 1. That is the average speed of the car. That is the average speed during the 0.5 second. The third one is, how high is the ledge from the ground? How high means we have to find the height of the ledge from the ground. So you take third one, h you have to find out. Then you write here which formula we have to use. We have to use s equals ut plus half at square, that is nothing but h equals ut plus half gt square. So you write here u equals 0, then v equals how much, 5 ms to the power of minus 1. Then t is time in 0.5 second. Then g, acceleration due to gravity, is 10 ms to the power of minus 2, that is given. Then what you have to find out, height of the ledge from the ground, h we have to find out. h equals question mark, you write. Then you write the formula, h equals u into t plus half gt square. So h equals, you write as 0 into t, it becomes 0 only totally, plus half into g is 10, t is 0.5. Then you can write 2 ones are 2 5s are, so you got 5 equals 5 into 0.5. 5 into 5, but it is a square, into 0.5 you write, because ut square, as it is t square, you must write 0.5 whole square. Then that becomes h equals 0.5 into 0.5 is 0.25 into 5. Then h equals 25 5 is a 125. The decimal point is 1.25 meter. So then what is the height of the ledge from the ground? That is 1.25 meter. Then you write the answer. First question here. What is the speed on striking the ground? The speed on striking the ground is 5 ms to the power of minus 1. And average speed during 0.5 second is 2.5 ms to the power of minus 1. Height of the ledge from the ground is 1.25 meter. Then you write the answer here. First answer, speed of car on striking the ground. On striking the ground, that is 5 ms to the power of minus 1. Next, average speed during the average speed during the 0.5 second, that is equals to 2.5 ms to the power of minus 1. Then the third one, height of the leads from the ground. Height of the leads from the ground, that equals 1.25 meter. That is the answer you got here. Now you take the next question. Next example. An object is thrown vertically upwards and rises to a height of 10 meter. An object is thrown vertically upwards and rises to a height of 10 meter. Calculate the first one, the velocity with which the object was thrown upward, and the second, time taken by the object to reach the highest point. So here what is given? The height is given, h is given, and the final velocity. When the object is thrown vertically upward, the final velocity is 0, and acceleration, the normally we have to take the g equals 9.8, but here the acceleration is negative, because when the object is vertically thrown upward, acceleration due to gravity is considered to be negative. So you have to take g equals minus 9.8 ms to the power of minus 2. So you take the solution here and you write one by one. H is given, h equals 10 meter, that is the height to which the object is thrown vertically upward. Then the final velocity v is 0, and acceleration due to gravity is minus 9.8 ms to the power of minus 2. Why have to take negativities? That is, the object is thrown vertically upward. Then what you have to find out? In the first case, we have to find the velocity with which the object was thrown upward, that is u, the initial velocity we have to find out. U equals question mark, that you have to find out. Next you write the formula here. H is given means you can use here two formulas are there for the H. One is H equals ut plus half gt square, and the other one is v square equals u square plus 2ah. You write that formula because here the time is not given. By using the given data we have to find the required. So you write the formula v square is equals to u square plus 2gs, but it becomes minus 2gs because g is negative. Here plus 2gs becomes minus 2gs. Then v is 0, you write u square you write because we have to find u, minus 2 into g, you write 9.8 because here we have taken negative, or if you write plus here then it becomes minus 9.8. That also you can take minus 9.8 as it is negative. If you take plus, then you have to take the g negative for the object when it is thrown upward. Then yes, h is here, in the place of s you write h. H is what? 10 meter. So you write that becomes 2u square minus 2 into 9.8 into 10 is 98. Then you interchange LHS and RHS, that becomes, or you write u is 0 is equals to u square minus 98 into 2, 2 8s are 16, 9 2s are 18 plus 1, 19. So you got 196. Then interchange LHS and RHS, that is u square minus 196 equals 0. Then you transfer this 1 minus 196 to the RHS, that becomes u square equals 0 plus 196. Then you take the square root on both the side. Square root of u square equals square root of 196. So square root of u square is u equals 196. 196 is square of 14. So square root of 196 is 14. The unit is ms to the power of minus 1. So then what is the initial velocity, or the velocity with which the object was thrown vertically upward? That is u equals 14 ms to the power of minus 1. Then you take the second. The time taken by the object to reach the height. So here you write u equals, you got, that is 14 ms to the power of minus 1, and v is 0. Then g is minus 9.8 ms to the power of minus 2. What you have to find out? T equals question mark. Then you write the formula. V is equals to u plus gt. If you are taking minus for the g, you write plus here. Then v is equals to 0. You write 0 only. Then u is 14. Then plus g is minus 9.8. T we have to find out. That it becomes, that is equals here. Then 0 equals 14 minus 9.8 t. Then you transfer this, because it is negative. When you transfer it to the LHS, it becomes positive. Then you write minus 9.8 t becomes plus 9.8 t equals 14. Then t equals 14 by 9.8. So to remove the decimal point, we have to take one more 0 here. Then you divide 145, 98. 98 ones are 98. Then 10 minus 8 is 2. And 3 is remaining here. 13 minus 9 is 4. 42. Point here, take 0. Then near about 4s are. 8 4s are 32. And 9 4s are 36 plus 3, 39. Then 10 minus 8 is 2 is 8. 11 minus 9 is 2, 0. Then you write one more 0 here. Near about 3s you can take. 8 3s are 24. 9 3s are 27. 77 plus 2, 29. Approximately you can have 3. Then you write 1.43 seconds. 1.43 seconds. Then the question for answer for the first question is, one is initial velocity. Initial velocity u equals 14 ms to the power of minus 1 you got. And the second one, time taken t. Time taken t equals 1.43 seconds. Now you write the answer for the in-text questions. There are two questions. First question is, what do you mean by free fall? What is the answer here? Whenever objects fall towards the earth under the earth's gravitational force alone, such objects are called freely falling objects, and such fall is called free fall. So what is the answer that you have to write here? Whenever objects fall towards the earth under the earth's gravitational force alone, such objects are called freely falling objects, and such fall is called free fall. Such fall is called free fall. Next, second question. What do you mean by acceleration due to gravity? What is the answer here? The acceleration with which an object falls towards the earth due to earth's gravitational pull is called acceleration due to gravity. What is the answer for this question? The acceleration with which an object falls towards the earth due to earth's gravitational pull is called acceleration due to gravity.